Welcome to VW 3.6. Today we'll be finishing up our lesson in identities, and I'm going to be showing you a various amount of techniques. We'll start right here at example 2. You're going to highlight right here, and this will be technique number 1, changing to sine and cosine. So clearly I'll pick my left side, there's more to work with there, and I'm going to change everything in terms of sine and cosine, like so. And I can see that this will become sine squared over cosine. This is cosine over 1, so I need a common denominator here. And look at that. We have sine squared plus cosine squared all over cosine. Okay, highlight that thing right there. This should always trigger in your head. That's something we know. That's 1. And now we have our answer, secant x. Circle, happy face. Now let's go to example 2. This will be technique number 2, factoring. So clearly, once again, the left has more to work with. Let's factor out the cosine. That's 1 minus sine squared. And again, once you're here, highlight this piece right here. You have to recognize that you know that. That's a Pythagorean identity. That is cosine squared. And now we have cosine cubed, which is exactly what we wanted. We are done. Okay, so first 2 examples, not too bad. Example 4. So this says we have 2 techniques. So to illustrate this, we'll do the left and the right. We'll start with the left side. The left side is a pretty cool technique. I call it fraction splitting. That's when we're going to take this fraction and split it. So we have 1 over cosine plus sine over cosine. So notice how we just take this thing and split into 2 separate pieces. And now we have secant plus tan, which is exactly what we wanted. It's a pretty cool technique, very useful. Let's draw a line here. Let's say you pick the right side. For the right side, we'll change to sine and cosine. So that'd be 1 over cosine plus sine over cosine. This technique is a bit more simple. This is simply creating a common denominator. So we can see we're adding 2 fractions, and actually this one's nice because they both have cosine already. So we'll just put them together. 1 plus sine over cosine. And there's our example right there. So again, 2 techniques. You have fraction splitting here and creating a common denominator. So we'll put a box on that, box on this. Okay, next. So now we have a little more involved example. It's going to involve quite a few techniques. So clearly we'll pick the left. So we'll drop our equal sign. Now a lot of people want to take this thing and split the fraction. And what you have to understand is that wouldn't be a good idea. Because if you were to split this, let's see what happens. If you're to do this, notice that you're creating 2 terms, meaning more terms, but this is your goal. Right, we're trying to get to here. And notice the goal only has 1 term, which means you actually don't want to create more terms. So fraction splitting here is not a good idea. Instead, let's do common denominator because we want to combine these 2 things. So this one on the left, we'll need cosine top and bottom And this one on the right, we need 1 plus sine, top and bottom. So put together, cosine squared plus 1 plus 2 sine x plus sine squared, all over your common denominator. And notice how I want to leave it factored on the bottom. And again, you want to highlight these two pieces right here and take a moment to think that you know what this is. These two things make 1. So now we have 2 plus 2 sine x all over our denominator right here. And then let's actually factor this. So it's 2 times 1 plus sine x, cancel. And now our answer is coming together. That would be 2 secant x. Done. Okay, 2 more examples here. These will be a little more advanced. So I'm going to show you some advanced techniques now. For this one, if you look at either side, they both look pretty similar, so it really won't matter which side we pick. Just for fun, I'll pick the right side. And by looking at this, there's not a lot you could do. You could separate it if you're thinking about separating the fraction, but then you'll notice nothing really happened, especially how we're going to get to this thing at the end. What we're going to do is a special technique called the conjugate. Now hopefully you remember this vocab word from earlier in the year. The conjugate is simply the idea that you have an a plus b and you flip the sign, so it's a minus b, and vice versa. So over here, we're going to multiply by the conjugate, which would be 1 plus cosine over 1 plus cosine. And the top, you'll notice something interesting happen. That's 1 minus cosine squared. The bottom is sine times 1 plus cosine. And highlight this thing right here. You know that. That actually becomes sine squared. And that's over sine x times 1 plus cosine x. And look at that. There's our answer. Sine over 1 plus cosine. Now, a lot of people will often say that seems pretty arbitrary. Like, how could you have known to simply do this? So I have a couple of conditions I usually teach. And again, these are loose conditions. So this is not foolproof. But this will help you understand when it might be a good idea to try the conjugate. So you want both of these things to be true. You want to see 1 plus or minus sine or 1 plus or minus cosine on both sides. And you also want to be in a situation where you have a fraction equaling a fraction. So like box over box equals circle over circle, something like that. If both of these things are true, the conjugate could be a good idea. But again, these are loose conditions. They do work most of the time, but this is not foolproof. It just helps you understand when you should try the conjugate. So let's try this next one. You clearly see I should try the left side. And a lot of people, when they see 1 plus cosine, they think, oh, I want to try the conjugate because I see that 1 plus cosine. And you could, but you'll find that it's going to get pretty complicated. And if you look at the conditions, you'll see, while you do have this fraction equal fraction, right, because tangent, that is true sine over cosine, we definitely don't see this on both sides of the equation. So we're not going to try conjugate here. So I'll make a note. Don't do conjugate. It's probably not a good idea. But maybe we could do it and it would work. It's just going to take some time. So instead, let's just try our standard techniques. Let's change tan into sine over cosine. Sine is odd, so I'll bring that negative out. And we have this. Now, once you're here, you'll notice something interesting. You have a fraction within a bigger fraction. That's called a complex fraction. So the last technique I want to talk about is clearing complex fractions. That's typically going to be a good idea. And to do that, you simply do this. Multiply by the LCD. So in this case, that would be cosine, meaning you're just going to get rid of that fraction right there. So now we're going to multiply that out. That's sine plus sine cosine, all divided by cosine times 1 plus cosine. The top I can see is factorable, and now we're kind of seeing it come together. This cancels. Sine over cosine is in fact 10. And we're done.